So yes, finally the wait is over. Finally, we are starting our Certified Kubernetes Administrator series. And this is the video number 1. If you are someone who has been following me for a long time, you would already be aware of what I'm talking about. If you are someone who just got into my channel, just to give you a brief overview, we have started a new series to cover end-to-end curriculum for Certified Kubernetes Administrator CKA course as per the latest guidelines, as per the latest exam guide of 2024 by CNCF, and we'll be covering everything from basic, like start from the Docker, and then we'll move up the ladder as per the playlist, right? It's gonna be a long series. That is why it took me some time to release the first video, because I was working on the content and I wanted to make sure that I record at least half of the playlist so that you don't have to wait for a long time to get the new video, and I should be able to publish at least 3 to 4 videos per week, which makes easy to follow along, which makes easy to be in that rhythm. So this first video will be focusing on Docker fundamentals, because yes, if you are beginner to Kubernetes, I am assuming you are beginner to Docker as well, beginner to containers. And if you have already a good understanding of Docker, then feel free to skip to the next video, else follow along with me. And like always, like I said in the previous video, it takes a lot of time and effort to create something like this big and to make it available free of cost. So please support me in this journey. I'll be giving you certain targets for likes and comments for every video. Please make sure you complete that. So target for this video will be 100 comments and 200 likes in 24 hours. I mean, it will be a piece of cake for you. So please do that so that I should be able to publish the next video as soon as the target is completed. All right, so let's jump into this video. Okay, so before understanding what are containers and how they work, we need to first understand why do we even need the containers, right? So for that, we need to understand the challenges that we had prior to containers. So let's say you are working like with the build promotion in the traditional way. That means prior to containers. So you have, let's say, 3 environments: dev environment, your test environment, your prod environment. All right. And you have a developer or a team of developers, and that developer, checked in some code, worked on some feature, and merged that code into the version control system. Builds get created, and the build is deployed into the dev environment, right? And it is working fine, which is what we all want to see, right? If you have a code and you want to see it up and running, that's the first step, and then you work on enhancing it, you work on making more changes to it. But let's say it is working fine in your dev environment, and so you promote it to your next environment, which is test environment, and it is working fine there as well, because usually dev and test environment, they have identical configuration, infrastructure, and everything else. Now when you promote that build from your build repository, the one that is already been working on dev and test environment, and you promote it to your prod environment, it gets failed. There could be multiple reasons for that build to fail, but most important one and the most frequent failures that arises because of these situations was due to environment misconfiguration, or due to missing dependencies, or due to many other libraries that were there in dev environment and test environment and missing in your prod environment, because you cannot do changes randomly in your prod environment. You have to go through a change request process. You have to get all the approvals before you even touch your prod environment, right? And it results in a lot of misconfiguration and misalignments between different environments. So the developer goes to the operations team, and the usual lines, the usual things that you have heard multiple times you are working in an organization, that it works on my machine. So it's not the issue with the code, it's issue with the infrastructure, or it's the issue with the environment. And then there'll be a lot of baffling between developers, ops team, and all the teams in between, right? Why it is not working in prod when it is working on the lower environments? So that's the issues that we had, because there was no easy way to package all the dependencies, libraries, configuration along with the application code inside the build and ship it to all the environments including prod, right? So that's when containers came into the picture. Now let's say, how do we do the build promotion, the container way or the Docker way? So let's say the same thing, it's working fine in your dev environment, it's working fine in your test environment. Now we are shipping everything with your dependencies, libraries, application code, and everything that a build required to execute, including the operating system image. And then it works in your prod environment. So there are likely any chances that it will fail because of the environment misconfiguration or because of the infrastructure misalignment. There could be many other reasons like some networking issues. There could be the infrastructure itself is not healthy and many other things, but it will not fail because of these issues that we have just seen, right? So your developer will be happy, your operations team will be happy, and everyone will be happy in this scenario. Now let's have a look at what exactly are the containers. As we have seen, it provides you an isolated environment with all the libraries, all the application code, runtime, operating system, dependencies, and everything that an application needs to run, right? Irrespective of the operating system, irrespective of the host operating system where it is running. So your application code could be in Ubuntu, CentOS, Red Hat Linux. It will work the same way in all the systems, right? Because doesn't matter what the host operating system is, your guest operating system will be packaged inside the container itself. So if you are getting confused, don't worry about it. We'll cover everything. I'll try to explain it as deep as possible. So just be along with me and it'll all make sense. Right. So as I've said, it's an isolated environment, and it is also sometimes referred to as a lightweight sandbox environment. Why lightweight? Because it will have the operating system image, but it will not have the entire operating system. It will not have the entire Red Hat Linux, or it will not have all the libraries and binaries that comes along with the vanilla installation of the Red Hat. It will only have the libraries, packages that is needed for your application to run, right? Only the bare minimum it will have. So the image size is really less as compared to a whole operating system, right? So the main goal of a container is to build, ship, and run your application code. Okay, so this is a three-step process: build, ship, and run. And people often get confused between containers and Docker. So Docker is nothing but a platform that helps you execute these tasks. So Docker is a platform that helps you build, ship, and run your containers, right? It provides a medium for you to execute all these tasks. So other alternative of Docker is Podman. Podman is also being used these days to execute these tasks. But Docker is the most common platform that most of the organizations are using, right? So basic overview of what Docker is. Okay, now let's try to understand the difference between a container and a virtual machine with the help of a small analogy. Right. So let's say you have a virtual machine. A virtual machine is nothing but virtual computer, which has the computing power, which has the storage, which has CPU, memory, networking access, operating system installed, and everything that it needs, right? And containers we have already seen. Now consider virtual machine as an independent house and container as a building, right? Inside a virtual machine, you have binaries, dependencies, and these can be viewed as windows of a house, and your application, which is your family, like where are you residing? And it works on an isolated infrastructure. So your operating system will be shared across the house, across different rooms, and wherever you go inside the house. But it is for one family. That means this virtual machine generally works for one application. And when we compare it to containers, containers have shared infrastructure. Your entire building is shared among many different tenants or many different flat owners, but they are isolated. You don't have access to each other flats without authentication and authorization. it is still isolated, but they share the infrastructure, they share the building, they share the land where the flats are being built. So every flat or every container has their own set of application binaries, dependencies, and operating system, right? And if you see, when it comes to house, they have binaries, dependencies, application code, operating system, everything is shared by the entire house. So that's the main difference between containers and virtual machines. If you look at this from the perspective of a builder, the builder will be able to save a lot of cost over here, right? Because they are not creating separate flats on separate lands. They just bought or they just leased a piece of land and they build the entire infrastructure on that piece of land. And it is being shared by a lot of families. So that means a lot of income. That means a lot of applications are running on the same shared infrastructure. So there is a minimum wastage of resources in containers. But when it comes to a virtual machine, around the same piece of land is shared by only one family. That means only one application is accessing that virtual machine. So there is a wastage of a lot of resources. If you look at this from the perspective of a builder for application, that means for a family, it doesn't matter. They have the money, they can definitely own a house. But let's say this house has 6 rooms and the family has 3 members, 3 rooms are still vacant. 3 rooms are not being used, they are underutilized. And this is one of the problems that container solves. It makes the optimum use of infrastructure. It makes sure that all the application, all the containers that are running only use the resources like your memory, CPU, storage. They only use the resources that is required by them, right? And they can scale up and down based on the requirements. So that's a basic difference between container and virtual machines. If it is not clear yet, so have a look at this 2-minute animation and it will make things more clear. Before we start containers, let's talk about how a virtual machine is provisioned. So you have your physical server that sits somewhere in the data center in case of a public cloud or your personal desktop. On top of that, you have an operating system that lets you interact with the physical machine, such as Windows or Linux. Then you have your hypervisor, which makes this virtualization possible. Now, what exactly is virtualization? Well, it allows you to run multiple operating system instances concurrently on a single computer. That means you can run Ubuntu, Fedora, CentOS all at the same time on top of your Windows machine with the help of virtualization. In case of a public cloud, your physical server over here is a shared hardware that is being used by multiple organizations and users at the same time. When you request provisioning a virtual machine through a cloud console, it lets you provision a guest VM on top of the hypervisor. But at the same time, other users and organizations are also using the same physical hardware underneath with a separate guest VM. Each user install binaries and libraries on top of it and then your application. A virtual machine is a software emulation of a physical machine which allows multiple operating systems to run on a single physical machine. Virtual machines are also isolated from each other and from the host machine, which provides security and stability. Now, if we talk about containers, it has the same physical server underneath and host operating system on top of that, but instead of a hypervisor, it has something called as container engine. Well, container engine allows you to run multiple container instances on a single operating system kernel. It works the same way as hypervisor but for containers. As hypervisor is for running multiple virtual machines on a single operating system, container engine allows you to run multiple container instances on a single operating system. Container has a lot of advantages, like they are lightweight alternative to virtual machines with all the required libraries and binaries packed within. Containers share the host operating system kernel, which makes them more efficient and portable than virtual machines. I'm sure you have a pretty decent idea now what are containers, how do we work through it. But even if it is not clear, don't worry, we are not done yet. So the next part is what we wanted to cover is a simple Docker flow. Like how does it work? How do we build our application? How do we ship it? How do we run our application with the help of a Docker container? So let's see. We have a Docker file, which is usually a set of instructions, right? It is nothing but, let's say, use this operating system as the base image. Let's say, for example, Ubuntu. Okay, now install these dependencies on that. Now copy these files from my local system to that container and run this command to build the image and so on. So usually if you are working in an enterprise, usually your developers are responsible for creating the Docker file along with the application code. If you are working on a self-hosted project or if you are working in a small organization, usually a startup, basically you do that as a DevOps engineer or as a because developer and DevOps engineer are same in the small organizations. So in any case, even if you are working as a DevOps engineer, cloud engineer, or as part of operations team, you should know how to create a Docker file, what are the different instructions in that Docker file, and so on. So this is really important from the Docker perspective, from the roles and responsibilities perspective, right? So we'll see everything, don't worry about it, but for now just try to understand. I'm taking one step at a time so that you don't get overwhelmed with a lot of information. So we are going slowly and we'll be going slowly so that you are aware of what's going around. Okay, so we have a Docker file which has set of instructions we have already discussed. Now you build that Docker file to create a Docker image, right? Again, what is a Docker image? So remember, we have discussed about dependencies, libraries, application code, operating system. Everything will be packaged in a image, right? So this image is the shippable image. This image we can ship from one environment to another. We can ship from one environment to multiple environments. So that's what a Docker image is. You cannot ship containers directly from one environment to another. The way you ship it with the help of an image. You run the Docker build command and Docker build will create the Docker image from the Docker file itself, right? So once you have the image ready, now you cannot directly even push the image, let's say, to the dev environment or to the test environment or directly to the prod environment. You cannot do that, because this is not the best practice. This is not something that you would want to do. So you need an intermediate storage. You need a registry to store those Docker images. Why do we need a registry? It is for the same reason why you need a version control system to store your source code, right? So you need GitHub, Bitbucket, GitLab. You need a version control system to store your source code, right? You don't store your source code on a Google Drive or on a Dropbox because that is not meant for this purpose. You want a repository, you want a storage that will help you track the changes, that will help you make it easy for you to make the changes and easy to maintain, right? For that purpose, we have a version control system for the source code. But for storing the Docker images, because these are the binaries, these are not in the form of flat files, these are the binaries. So for that, you need to have a Docker registry, right? So there are different Docker registries. The first one, or the one that comes with Docker, is Docker Hub. You might have already be aware of what Docker Hub is. So Docker Hub is nothing but a Docker image registry where you store your Docker images, and that will help you ship your images from one environment to another. Till now, we have built the Docker image from the Docker file. You have pushed the Docker image to the Docker registry. Now you will be pulling that Docker image to different environments, to dev environment, to test environment, to prod environment with the help of Docker pull command. You do that and the Docker image will be pulled to that environment. So those binaries will then be pulled to that environment, and then you basically run the Docker run command. Docker run will make sure that that image, the package that we have, which is called the Docker image, that image will be converted into a running instance. Now your instance will be up and running. Your application will be running on dev environment, test environment, and prod environment with the help of Docker image that you just pulled. So there are different other Docker commands that we can use, but this is the basic workflow. Like, how do you build an application? How do you ship an application? And how do you run your application when it comes to containers? So this is a simple Docker flow. Now let's try to understand the Docker architecture. Okay, again, don't get overwhelmed with this. This looks complicated because I have tried to include a lot of components within this diagram. But once you start working on it, once you do the hands-on, which we'll be doing, and once you start doing that, this all will make sense, right? So this is nothing but the Docker flow that we have just discussed. It just have the components that is responsible for doing each of these tasks, right? So here you have your client, okay, where you have your Docker client installed, from where you'll be running the Docker commands. So these commands, let's say the first command would be Docker build. So you have a Docker file usually stored in a version control system such as GitHub. This Docker file, as I said, is a set of instructions, and the name of the file is, this is the default name, Docker file with the D in upper caps, but you can change this name as per your needs. However, this is the best practice and we should, keep it default, Docker file. Usually you have one Docker file per application. Now you run the Docker build command, and that Docker build command is then issued to the Docker daemon, right? Docker daemon such as Docker D, which is the default daemon for Docker. And that Docker daemon is then build the Docker image with the help of Docker file, right? And then the image is stored locally. Let's say you are building an Nginx container, right? So then this is the local storage that comes with the Docker host itself. So now this image will be stored on your Docker host, the virtual machine where your Docker is running. So this image is local now. Now the next step, you need an intermediate storage. You need a image hosting registry to store this image so that we can ship it to the next environment. So then what you'll do is, again, the Docker daemon, you run Docker push command. This Docker push command will again interact with Docker daemon, and then it will push the image from your local registry to a image registry. These image registries could be your Docker hub, it could be your artifact registry, it could be a JFrog artifactory, it could be Nexus registry. There are a lot of options available, right? So this Docker image is then pushed to a registry. Once that image is pushed to a registry, now you want to deploy that image to an environment. So for that, you will be running Docker pull command on the environment. Now this client will be running on the environment, let's say your dev environment. So now this Docker client is running on the dev environment, and then it will pull the image. You issue a pull command. Again, it will interact with the Docker daemon, and that Docker daemon will then pull the image from the registry to the environment, right? It will then pull the image. Once the image is being pulled, then you run Docker run command. Docker run command will then be issued to the Docker daemon. Docker daemon instruct the container runtime. Container runtime will then spin up the container based on the instructions, based on the image that it pulled, and based on the command that it issued. So this is the entire architecture of a Docker container. It will have a lot of more details, but I just don't want to complicate things at this moment. So we will be covering many more things as we go later in this course. So don't worry about it. Just have some patience and just stay along with me. Now we have seen the basic, the fundamentals of containers and Dockers. The next part is to Dockerize a file and see everything in action, see everything that we have just discussed so far. How do we build an application? How do we Dockerize it? And how do we run an application in a container? So I think we have done enough for day one. I think this will be a lot for you. So let's continue that on day two. And please remember the target for your comments and likes. Please support me in this journey so that I should be able to publish the content as soon as possible and If you have any doubts, any question whatsoever, feel free to let me know in the comment section below and I will be gladly answer those questions. And we have a Discord community as well. You can find the link in the description. Join our Discord community. There will be a dedicated section for this entire playlist. It will be called Help CKA 2024. So post your query in that and someone from the community will help you, or try to help each other in that community, because this is a learning journey in which we are together. So let's do that, and I will see you soon with the next video. Thank you so much for watching. Happy learning, and I wish you have a good day.